be seeing that as well. Okay, so the title of the talk is What's Wrong with Users? And you might notice here that users is quite intentionally in quotation marks, and should become clear why this is so. One important thing I have to say is, although some of this stuff is not flattering to people, including myself, if you like, because I suffer from the same syndrome that is a problem here, the problem that I'll be talking about. It is, if you like, a reflective look on us being the software developers, software engineers, the community, and some of the issues that we have foisted upon the people who use and are in some way victims of the systems that we build. Now, also towards in the process of going through this, I'll be talking about potential remedies, and in particular, towards the end of the presentation, I'll mention a particular initiative that we're doing at Monash University. If you have any questions, there's my email addresses. You can use either one, or if you have comments and suggestions, and of course, if you're interested in following up in any way, do feel free to contact me. The Rowan Atkinson, if you recognize Mr. Bean here, it's quite intentionally chosen, you'll see why. So start off here by making a very clear distinction here that this is not necessarily the result of a very systematic survey and questionnaires and all of that, a systematic review of the state of the art and the state of the practice. It's based, though, on 50 years of direct personal experience. I've got almost 50 years of actual work in the software community, in the software domain, and working in particularly large industrial software systems. And over that time, and in a variety of environments, and during that time, I have actually accumulated a fair amount of opinions about not just software, but also the people who do software. And to be clear, as I said, I'm also prone to all the issues that I'm going to be pointing out here. But here, let me just give you a very quick overview of what my experience is. And it started way back in 1969 when I wrote my first computer program as a third-year student at the University of Belgrade. This was in old Yugoslavia. Fortran was the language that we learned, and at that time I thought, my God, there can't be anything better than Fortran, until this gentleman came around and told us about somebody called Dijkstra, who said that you know, you can do programming without go-to statements. At that time, we were all young and naive and very confident of what we knew, and we thought this person was not very smart and obviously didn't know what he was talking about, because clearly you cannot do programming without go-tos. It just is a lesson, if you like, in humility and how humble we should be about things that we're certain about. My first job involved working on software for controlling robotic manipulators. Most of that was done in assembler, a little bit in BASIC for a couple of years. Then I did a real career shift, and I did a lot of COBOL work involving financial applications, banking, insurance, and so on, as well as some domain-specific language. DSL stands for domain-specific language, which was actually at that time a very innovative language from Burroughs Computers, the language was intended to allow us to build languages. It was a meta language, if you like. In 1977, I moved to Canada, and there I worked on aerospace applications, most of it in assembler for aircraft simulators. I also actually worked on, using Fortran, I worked on the space shuttle. Specifically, I worked on the so-called Canadarm, which is now also being used. The third generation of it is being used in the space lab that is still around. I then did another career shift, or if you like, a domain shift. I moved to a company that was a telecom company. I worked for several years on telephony switching software using a domain-specific language. I switched to packet switching, if you like, which was at that time a competitor to the internet, TCP/IP. This was all based on international ISO standards such as X25 and so on. And at that point, I started working with distributed software systems. Particularly, I was involved in the design of distributed operating systems. And this is the time when distribution was now coming into its full fore. And we've now seen, of course, the results of that work, because after all, the application we're using here is a distributed application, and you can see that it's generally working fairly well. Okay, then I started my own company where we were quite successful, actually. We got bought ultimately by a larger company in the same line of business, which was software development tools. And we were involved in high-level language design, including things like UML. And in fact, I was the co-chair of UML, the standardization committee of UML for a number of years. Hopefully you won't hold it against me. We tried to do the best we could at the time. And we'll mention it a little bit more later on. Worked with a variety of languages. In 2007, I left the large company. Actually, I ended up working at IBM as a distinguished engineer. I ended up at IBM because IBM bought the company that bought my company. And since then, since retiring in 2007, all the way through to now, I did mostly consulting in industry and some academic teaching and research work on a variety of very different domains. That gave me a lot of exposure, not only to different cultures, different domain problems, but also different corporate environments and so on. So that's where all of the opinions that I'm going to express here come from. Okay, now this is the central theme of my talk, and it's exemplified, if you like, by a statement made by the gentleman that I'm sure you recognize from this photo. You can read this. I have underlined the principle, the highlighted, if you like, those aspects that I really want you to focus on. It's concern for man himself. That's the objective of technological endeavors. And we know that technology can be both blessing and a curse. I'm one of what I think the lucky few who I do not have a mobile phone. And you'd be surprised how often people respond when I tell them that I'm a lucky person not to have one, because mobile phones and smartphones and so on turn to be often to be curses as much as they are blessings. So never forget this in the midst of what you're doing. I'm really a strong believer in this line of thinking. Now you'll notice I posted this once to a bulletin board, and I got some reaction from a number of ladies who objected to the sexist language here, man himself, mankind, and so on. I'm sure that Einstein didn't mean it this way, but this is an interesting example of the kind of bias we can unintentionally introduce, not only in the way that we speak or work with others, but also in our software. And that's partly the theme of this talk. Now, as a trained engineer, I graduated as an electronics engineer. In my first couple of years, I actually worked as an electronics engineer. But even from my student days, I, if you like, was steered to the dark side and got involved in software. And almost all of my professional career has been in software. Now, so as a trained engineer, I quite often enjoy to do a comparison between classical engineering, such as what I was taught, and what I see in software engineering. So let's look at here an airliner cockpit. So this is from the early 1950s, and you can see that it's overwhelming. If you're not aware of what these things do, the first impression you have is that nobody can make sense of this. Only superhumans can maybe learn how to control an airplane using these kinds of diverse controls. Now, more recently, they have done, it's quite frustrating and intimidating, but even more recently, they have actually reduced the apparent complexity of it, even though the airplanes that are now being used are much more sophisticated than the airplanes of the 1950s. Yet still, when you look at it, there's still a fair amount of complexity there. There's probably a couple of hundred or maybe 100 or so controls there that you have to worry about. So as the gentleman down at the bottom there says, oh my God, this is intimidating. But if you think this is intimidating, let's look at the software side. Now, this happens to be an interactive development environment for modeling languages like UML, but it's typical of the kinds of development environments that people use. I suspect most of you are familiar with things like this. This one is based on Eclipse. And what you can see here is a lot of windows and a lot of controls. So here, for example, we have 11 different menu categories, which are groupings of menu items. Okay. Now, each of these categories obviously has a list of menu list of individual functions that belong to that category. And of course, there's 11 of these. So when you add it all up, there's over 300 distinct menu items, each one representing some kind of function. Now, as a user of such a system, you kind of have to, you're expected to know where these things are. You know, which of these menu categories can I find the view menu item, for example, the one that controls how I show my windows and things like that. And not only is it a question of knowing the 300 or so distinct menu items and their location, you are expected to know how to use them together. You have to use them, for example, something from the file menu, followed by something from the project menu, followed by something from the window menu, and so on and so on. And my experience, especially the consulting experience, some of these tools, in fact, this one was partly done by a company that I worked with, and I'm partly responsible for this. I found when people were using these tools, and I talked to a lot of people who were using these tools, I found that they, of course, even the sort of master tool users were often unaware of certain optimal ways of doing things. And they were actually spending a lot of time, if you like, fighting with the tool. Okay, so the things that they could have maybe done with one menu item, they would go and do 3 or 4, a combination of 3 or 4 different menu items to achieve the same thing, not because they were not smart, but because it was simply overwhelmingly complex. Okay, now here, for example, this exactly typifies some of these issues. You have this sort of shortcut menu bar here that gives you some common functions, but they're all identified by these icons that are supposed to be intuitive. For example, right down at the corner there, where at this thing here, there's a flashlight, and I'm somehow supposed to understand what a flashlight means. Eventually, perhaps I'm going to learn all of this, but these icons that were used there only really made sense to the people who actually designed this. They're not certainly universal things, with a few exceptions. So naturally, you know, the poor tool user is, of course, intimidated by this. And like I said, I find that, you know, the productivity of users is actually negatively affected. Productivity of software developers in this case is negatively affected by this complexity, right? This is the problem that I'm talking about. So what exactly is that? And by the way, I have to mention this. If you think this is how it has to be, this is the only way it can be done, then you are part of the problem. Okay, so what exactly is the problem? Well, let's look at it this way. Here's a software developer, a typical software developer. Well, maybe not typical, but I can tell you in my long career as a consultant and developer myself, I have seen people that had crazier hairdos than this gentleman here. So I approached, let's say, the typical software developer, and I asked them, well, how do they perceive the user, right? So what is their image of the user of their software? And quite often what you find is that they perceive somebody like themselves. And they're certainly not that typical, right? Because they, of course, understand the software that they're building. They understand software and how it works. And therefore, this kind of vision of the user tends to create this image that it's somebody like myself who is using this tool. And that tends to be a little overgeneral or too abstract or too simplified. But really the thing that I want to show with this particular slide is, where is the focus? The focus isn't so much on the user, but the focus of these people. And I have to admit, I was one of these people as well, that really coding was the thing that attracted me to software. And that was where the focus was. It was all in the code. I'll talk a little bit later about things like Agile Manifesto, which is basically really very much code-centric. So let's look at what does this mean, this when the focus shifts from the user and the product itself so much in particular, but focuses on the code itself. Now I call this the existential pleasure of programming, because this is one of the things that it not only attracts people to software, but also actually forms their character and their method of operation. So if I look at something like a traditional engineer, like say an automotive engineer, the designer, the engineer comes up with a concept of a solution and works that out and so on. And then that's handed over to some people who are supposedly implementing that and so on. And you might get a product, let's say an automobile. And the time gap between conceptualization and seeing the results of one's design ideas, one's creativity, is in the order of months to years. It involves creating maybe manufacturing facilities. It involves obtaining raw materials, all kinds of things that the pure physics of this is what gets in the way. Now, if we compare that to the software engineering thing, so here's that software developer who has a conceptualization of the design, types away, and out pops the working code. That's something quite interesting, because the gap here might be in the order of minutes, certainly not months. And one of the nice things about this is to see that you're able to see the results of your ideas become real, become actual implementations very quickly. All you have to do is type and maybe invoke a compiler, but it really doesn't involve much physical exertion and moving stuff or bending metal or what have you. The stuff that gets in the way. And this creates a highly seductive and, let's face it, very rewarding experience. It's nice to see. It's ego fulfilling to see your idea working. Even a Hello World program, once we try it the first time, we get some kind of kick out of seeing that stuff work. So it's a highly rewarding experience, and that leads to something that I call the medium is the message syndrome, which you may have heard from as something that Marshall McLuhan, a professor of philosophy in Toronto, stated. He talked about the medium and media like television and so on, and journalism and so on. And part of the message that he had was that we do watch television, of course, to see what it says, but the act of watching television itself is in some way gratifying and something that we seek. So that's what he means by the medium is the message. And we see that with software people, right? Yes, they use software to build things, but they get so immersed in that it becomes addictive. Look at that. It says eat, sleep, code. You can buy these coffee mugs, but it exemplifies this kind of attitude. So what we're seeing here is that the focus of these people, the implementers of the software, is that the product takes sort of second place to the actual craft of implementing the product. And this is where thinking and spending time thinking about users kind of gets in the way, right? So it's kind of a detour, okay? Because I'm not coding, I'm looking at and thinking about the user requirements and what is a good way to specify this requirement, how does it relate to that other requirement, and so on. And in the meantime, I'm not being productive, at least in my mind. And this is encouraged, if you like, or reinforced by some statements in the Agile Manifesto, which, by the way, has a lot of wonderful things in it, but it also, I think, reflects some of this attitude that I'm talking about here. It says develop only code and tests. So where do things like requirements come in? Where do I spend time developing my understanding of what is required? Working software and over comprehensive documentation. So if I have an image of my user, is that the correct image? How are other people going to know what my image is? If all I do is I produce code and it's somehow captured inside the code, who's going to understand what from that? What are the requirements that the user actually has? How did I interpret that? So there's this programmer culture that I think is a huge impediment in our, and I'll explain why even more later on. But you can see that software developer in the middle there on top that says, he's tapping away at his keyboard and he's got a coffee mug next to him because he's going to spend a fair amount of time on this. Do not disturb means I'm in the zone, get me going, and so on. What are these people expert at, and how do they perceive themselves? Where is their expertise? It's in the implementation technology, much less in what this implementation is about. It's the implementation, it's the code. And this is different, very different from being a problem domain expert. Okay. If you look at how these people identify themselves, they'll say they identify themselves by the technology that they actually have mastered. They might say, I know Linux, I'm a Java person. If you need Java programming, I'm the guy. Okay. They're not saying I'm a telecom software or telecom product expert with software expertise. No. That's the interesting thing. Again, as a classically trained engineer, this kind of the expertise in implementation technology is something that's normally left to technicians. Now, I'm not trying to be biased against technicians in any way, but there is a division of labor that engineers tend to be people who have to worry about the problem being solved, the problem and how to solve it, and so on. The technicians are given the task of, given the problem, the solution of implementing it. And of course, it takes a lot of time and effort to become an expert in these software technologies. Programming languages keep coming up, new development environments, new libraries, all of that stuff. So there's a tremendous amount of time spent on keeping up to date, maintaining your currency as an implementation technologist. And of course, market demand is very high these days. I can attest to that based on the number of people that are enrolling in IT courses, that some of which I teach. There's a lot of mobility here because there's a huge demand, and let's say software developers can almost choose the job that they want, right? And so there's a high degree of mobility, which means that there's a frequent employee. In my career, I've had at least 7 or 8 different kinds of jobs that I worked in, all in software. And the product domains can vary, in my case, from aerospace to banking to telecom and so on. And that, of course, means that there isn't much time left to develop this deep domain expertise, which is necessary. So what you end up with, unfortunately, is a lot of programmers, but few system designers, because in order to be a system designer, you have to know the problem. And you have to care about the problem, not just how am I going to implement it. Okay, let's go back to my comparison again. So let's look at an automotive example from the automotive engineering domain. So if you're an automotive system designer, you know that, for example, there are drivers who drive the car. There are passengers who sit in the car and are driven by the driver. There are mechanics who worry about maintaining the car, fixing the car. There's maybe even attendants and a number of other people involved that I won't go into. But they all know every one of these people is, of course, a user of the car in one way or another, but the users are very different. And of course, the automotive designer is very much aware of this. Now, if I were to give this problem to a software person, okay, what you'll see is all of these people are treated as users. And notice, by the way, this is very important, the car has gone away. That's the end product. But to the software person, really, it's the code is the end product, which may sound like I'm being a little bit facetious, but no, it's a big difference, because if you're thinking about the car and the different ways that it's being used, that adds a lot of complexity that goes beyond just the code. Okay, so what we have is, unfortunately, this sort of merge of very different things, different requirements, different needs, different individuals, if you like, into something called a user. And another syndrome that I see as a result of this sort of brotherhood, if you like, of software developers who know the arcane art of telling the computer what it can do, the arcane art of coding. And by the way, it's quite interesting that it's called coding, because coding has to do with translating something that's understandable into something which is not necessarily understandable. Anyways, what I have seen among software developers is, because they are so into computers and a lot of their people who are using their product are not, there's a bit of a disdain and something of a deprecation of the user. Like the users don't know what they want. They keep changing their mind, right? So that creates a bit of a negative view of the user. You know, it's the user doesn't understand software, so how can that user tell us what to do? Or in particular, the user just broke my software by using it in a way that is really crazy, right? So all of this creates, if you like, what I call a racist view. And unfortunately, I find that it's endemic in all the places, and I've done lots of studies of it, on personal studies, and I talk to people. For example, I'll ask them, do you know what the system that you're building does? A lot of them will know, of course, the portion that they're involved with, but they don't know the big system other than a very superficial way, which means that they don't really care that much about it. They care about their code. They're professionals. So don't get me wrong. I'm not trying to say that this is unprofessional, but just that understanding, for example, how say automotive software is being used by a mechanic and so on, needs a lot of understanding of how that mechanic operates and what he needs, and so, or she needs, and so on. So if we go beyond this version of what is just a user, okay, we'll see a huge number, and there's a term here called stakeholder, which is now becoming quite common in requirements engineering rather than user. We see a huge list here. And look at the bottom part here. These are all internal stakeholders. These are all people inside the development organization, the organization that's actually producing the product. It includes the designers, programmers, and the architects, and the testers. All of these people should, of course, have some input on the product. For example, if they're asking you to use a technology that you have no access to for whatever reason, you have to tell them that, of course, either you're going to have to pay for us to learn how to use this technology, or we're not going to be able to produce that. Now, when we come to the user concept, well, usually what people mean is just this subset here. But if we look at that long list of things there, and this is not a complete list, all of them actually have further subcategories or sub-stakeholders and so on. And each of these has an idiosyncratic and possibly even conflicting concerns, conflict in the sense that your concern may conflict with somebody else's concern. So the generic term user obscures this very important difference, okay? In fact, I go as far as to say, whenever I see the term user being bandied about without any qualification, either in a requirements document or actually in design discussions, I see that this is a possible red flag needs to be raised, because it could be a sign, almost a sure sign, that the requirements are not sufficiently understood or they're not sufficiently refined. So let's try and build a bigger picture of all of this, the relationship, say, between stakeholders and requirements. So for this, I'm going to use a UML class diagram. Not all of you may be familiar with UML. A class diagram basically talks about concepts that exist in some domain. In our case, the requirements engineering domain. The concepts that exist, like stakeholder and system requirement, and the relationships that exist between them. So stakeholders are groups or individuals who produce system requirements. An individual stakeholder can have multiple. The star here means 0 or more, open-ended. A stakeholder can actually be responsible for a number of system requirements, and a system requirement may be created by one or more stakeholders. Okay, so that's the UML class diagram. Now let's go into it. So this is just the stakeholder part. But one of the points I want to make is that we go, and these are the people, as of course, that produce the actual, have a direct input on the system requirements. Okay, but there are other people who are affected by the system. I'm going to call them the affected parties. Okay, and they come in different types. Okay, so the affected people who are in some way affected by the product, okay, but don't actually have, for one reason or another, they don't actually have the right or the input, the ability to specify system requirements. So no direct input to system requirements. However, they are affected by the product. What are the categories? Let's start off with, in UML, by the way, if you look at this, arrow here, so there's an arrow from collateral party to affected party, okay, from an opponent to affected party. This arrow is, you can think of it as inheritance. It's subtly different, but let's not worry about it. In other words, an opponent is a kind of affected party. A collateral party is a kind of affected party. Let's look at opponents. An opponent is, of course, somebody who actually, for one reason or another, doesn't like the system and is prepared to actively interfere. Of course, we have hackers who might want to get inside the system and corrupt it in some way, or it might be a competitor and so on. So there are these people who are opponents. For example, if you're worried about privacy, they're not going to tell you about what the requirements are. Okay, but they have requirements. Yes, what about these collateral parties? Well, I've just roughly grouped them into two groups. A casualty is somebody or some group or some entity that is actually harmed by the operation of the system. You can think of some examples that are quite current now. For example, we have these facial recognition systems that are known because of their machine learning algorithms are biased in one direction or another, that they will misclassify people, and that can lead to all kinds of problems for these people who are innocent bystanders, of course. Nothing to do with the system yet. They are victims of it, if you like. And of course, there's also the other category who are not intended, but in one way or another, they're beneficiaries of that system. Okay, so there's all these different categories, and of course, different kinds of stakeholders that we already talked about and so on that are not shown in this slide. But let's come up with a common concept that all these people that have an interest in the system. So I called them here partly with interest. So parties with interest have an interest, and they all work like all people. They have, sorry about that, they have a goal. Okay, so the goal is, so a party with interest can have 0 or more goals that they want achieved, whether it's by using the system or by whatever. For example, somebody who buys Bitcoins can be a party with an interest in a software that dispenses Bitcoins or works with Bitcoins. Okay, so they have a goal. Now, goals are also what stands behind system requirements. So system requirements should fulfill one or more of these goals. Now, the goals, of course, themselves are supposed to provide some kind of value. Okay, So there's this notion of a value, and a goal fulfills a value, and values are things that parties of interest that really are is the motivation. So when people are motivated, they're typically motivated by some kind of value, that's something that has value for them. We're going to talk about values in a few slides, a little more. And last but not least, there's this notion of a context, because different individuals, depending on the context, are going to have different values and different goals and so on. So context is quite an important thing, and I will explain what I mean on the next slides. Next slide. So let's take a different picture. This is known as the onion model from requirements engineering. It talks about stakeholders, focus on stakeholders of different kinds. And of course, there's the system, and in direct contact with the system is what they call the socio-technical system, which is, of course, the system does something from a sociological or business point of view. And in direct contact are these stakeholders, like the client, or if you like user. I really don't like the term, so I'll quite often use the term client instead, but even that is not a very good term. It's almost as amorphous as user. And then we have a system operator. Okay, that's the person, individual responsible for the actual maintenance and so on and so on. And then, of course, all of this may be part of a greater business system, for example, which is called the containing system. And there I might have the system owner, I might be a business. There might be the system integrator who is responsible for the IT of the entire business and so on. Okay, and then of course all of this sits in the world, which is here called the wider environment. There might be an investor who invests in such a system, a regulator who worries about things such as does the system operate legally, or does it violate some bylaws or laws and so on. And of course, people like hackers. And just to go back to the Agile Manifesto and the programmer mindset and programmer culture, notice this, by the way, the Agile Manifesto does not talk about these different categories things. They talk about something amorphous called a customer. And is that the client? Is that the system operator? Is the system owner, investor? All of these are in a sense possibly clients, or maybe one of them, but not differentiating this is exactly the problem that we're worried about here. So if we take this broader picture of things, look at that. First of all, notice we're not at the level of coding yet, and yet we need to understand this in order to know what to code. There's not even, if you know UML and things like use case-based approaches, we're not even at the use case stage, where in the use case you might say, here's how I achieve the goal of getting money from my ATM machine. Okay. So the Agile Manifesto will say produce only code and tests. But how am I going to know whether the code actually meets this? And the tests necessarily are going to be, of course, driven by the code and so on. And how are the tests going to be written unless they also have an understanding and embody the stakeholders and all these parties with interest and so on. And this requires, if you see over here from the slides over here, you'll see that there's a lot more here than just coding. There's problem domain expertise needed. There's software engineering, of course, needed. There's maybe social business, and you have to understand, for example, why does the system owner want the system? What is the value that the system brings to that individual or that group? So one technique which has emerged, has been around for a long time, but it's not all that known, is something called personas, which tries to get around this problem of an amorphous user which has no name and so on, which is reduced to, if you like, not this silly user who doesn't understand software, but maybe somebody like this. Okay, and that concept, of course, is too abstract and reductionist, and it's hard to identify with something like this. So the idea of personas is to actually provide some kind of individuality so that it becomes closer, so that developers can get a closer understanding and become much more emotionally and empathetically attached. So there's this notion of the persona concept, which is an imagined individual that is typically the result of maybe talking to a number of different users, and then you identify the goals that these users have that they share and come up with a persona, but you actually attach to it a particular identity, if you like, and we'll see what that means in the next slide, right? Like I say, the concept is way back, it's over 40 years old now, but it actually works quite well in the sense that it creates a much closer empathetic bond and the desire in the end to satisfy that persona and a greater appreciation of human factors. So here's one that actually comes from real practice. So here's a persona that was developed to work with a parking app. Now the parking app is supposed to tell you where are the free parking spaces in a given parking lot. And somehow through electronic Internet of Things connections, they can find out what exists, what's available, what isn't. So here's the persona given a name. This is called the demographics part and age and so on. And then we talk about the goals of that persona. For example, this individual needs to bring her husband to the hospital every week, and the husband needs to take health care, and therefore it means have to go to the parking lot and park somewhere and so on. And unfortunately, this particular individual has has what is known as a protanopia, if I can pronounce that correctly, which is a color blindness. In other words, this individual does not perceive the color red very well, does not distinguish it very well. So there's more details on this, but this particular thing, in this particular case, this individual got a smartphone. She is smart and so on. She knows how to use a smartphone. Unfortunately, the parking app uses red to identify busy spaces versus open spaces. So there are some frustrations that come with it. Now, once we have an individual like this in front of us and with all those little details, it becomes much closer to us. And we find ourselves much more inclined to help this individual with our software. So this persona thing works quite well. And the whole idea of human factors is quite interesting here. I love this cartoon because you can see that there's this dissonance between the individual, the human, and the computer, right? There's a completely different world here. And the problem is that we're getting a lot more people on the left who are not computer trained. Right? So humanity is now increasingly with things like smartphones. Everybody has to use the web in order to live a normal life these days, right? So the use of software is no longer just specialists. The use of software means that we're going to have all kinds of different users, technically savvy, technically not savvy. We might have people who are colorblind and people who are not. We might have people who have physiological difficulties, whatever that might get in the way here. And unfortunately, the current model that we have is simply not adequate, and we must evolve it to deal with this tremendous diversity of needs. So the question that we need to address is, how do we develop software engineering methods to deal with this issue? And to technologies, tools, and so on. So here's just an example. These are all kinds of different biases. Age bias, gender bias, ethnic bias, language bias, physical challenges, socioeconomic status biases against people who are not perhaps who don't stand well financially from people who do, and health and so on. And of course, there's a huge number of these, and you have to be aware of these. How can we detect that we have done something unintended? We've produced an unintended bias like Einstein did there. And how should we design software to avoid it? How can we make our designers aware of these things so that they take it into account? What kind of tools can help us with this? And which human aspects should we consider? Which brings me to this idea of human-centric software engineering. It's an expanding research area. I'll talk specifically about the project very quickly at this is the end of the presentation, if you like. The HumaniSE research project at Monash University, you'll notice that the last two letters SE, as in software engineering, are capitalized here. So we're focusing on the human aspects related as they relate to software engineering. Here's a panel, a poster that we have. You can read this. I'm not going to go through this. There is a website you can visit, and you can also contact us through email. The overview, it's a program. It's a multi-year program run by the Australian Research Council, and the chief lead is Professor John Grundy, who is a laureate of the Australian Research Council. The key issue that's being addressed is the current software engineering approaches that unfortunately ignore many human-centric issues, or if they don't ignore them, then they solve them in ad hoc ways, and we want a much more systematic and proven way of doing. And these are the general research directions. There is something called the Living Lab, which is explained on the next slide. And we want much more human-centric requirements considered in and investigated engineering methods, such as how do we identify stakeholders? We want to incorporate human-centric issues. We want to develop in the design methods, so new methodologies and the appropriate tools to support them. And we want to run trials and real-world examples with large-scale industry partners. Now, here's the Living Lab idea. It's a model-based approach. We believe very much in models and model-based engineering, as you'll see. A common term there is a domain-specific visual language. We believe in visual languages because they tend to remove a lot of the biases that, say, textual language will produce, but also because they tend to be much more intuitive if they're well designed. So here's the idea. We have this Living Lab, which comprises a groupings of different kinds of user categories or stakeholder categories, as well as the developers and the researchers. They all collaborate to produce requirements. And from that work, we extract the appropriate requirements and develop appropriate modeling tools to help people express these requirements and so on. Based on these tools, and languages that are developed. There might be a specific language for a certain kind of application domain. We use model-based technology to automatically generate code from, say, a language specification. Believe me, I have been working on automated code generation for the last 30 years, and it's a lot farther ahead than most people imagine. And usually it produces better code than most programmers. Okay, so now we have these code generators, and then we test the results of this, and then that's fed back to the Agile Living Lab. And of course, even for use model-based testing methods and so on. Just an example, remember the value part I talked about? Well, there's Schwartz's so-called Schwartz's theory of basic values, which is a taxonomy of different kinds of values that people in general have, such as social justice, self-discipline, intelligence, and so on, self-respect, etc. And if we use this wonderful taxonomy here and check that against a whole bunch of different applications, what we found when this was done was that different applications have violated a number of these. For example, that application down there called Celopark violates what is the curiosity factor for one reason or another, right? So we want to develop tools that analyze this. So here's a list of, far from complete list, of different research projects, all of which have associated PhD opportunities with them. So to summarize, basically we're saying that the current methods need to be expanded, right? Unfortunately, the reason the current methods are inappropriate, are inadequate, is this attitude of the message, the medium is the message. And that means that we not only need to advance some software engineering method, but we also have to advance the software engineering culture, because there's this tremendous diversity that we have to deal with. So the idea of human-centric software engineering is based, it looks at new research that produces new methods and new tools for human-centric software. And to conclude, I just want to remind you of Einstein and his a blessing and not a curse guidance. Thank you.